Good morning. What I wanted to do today is actually take you through the process of going from zero to hero, building a 3D base map in a 3D city. And it starts with a hero. So this is one of our heroes for Geelong. It is St. Mary's of the Angels. It's one of the churches. It's a beautiful textured building, and it's a hero building. These are the ones that we want to see. They give us our reference to a location. And we want to use these as to build part of our 3D city. But there's something you're going to notice here, and I'm going to zoom out. It's a little bit of 1 is the loneliest number that we ever knew. It's not just a hero, it's actually also a 0. And when I say it's a 0, it's a 000. It's a 3DS file. It has a geographic location. It's 000. It thinks it's someplace west off of Tasmania. So what we have to do is take this hero building, give it its context, and put it into the city so that we actually know where it is. So here is Geelong. We can actually take a look at it and see the kind of data that they have. On the right side, we have the 2D view. On the left side, we have the 3D view. So if we zoom in, we can actually take a look at the location of where this church is located in geographic space. So it's this little orange building here on the right side. And what we want to do is quickly georeference that building. The first challenge, of course, is it thinks it's in 000. So we actually wrote a little model that went in and went through every single model that they had and stripped out that geographic location, converted the model into a collada model. And they had a really nice set of point data that actually showed us where this building was. So here I've brought in those points. So I'm going to reach out and grab a tool. Import 3D files is the native interoperability tool. I'm going to grab that, reach out, grab St. Mary's. Going to call it St. Mary's. Give it its local context, local coordinate system, grab its placement point, reference which model we're doing, and drop that into 3D. Okay, so there we see St. Mary's. We can go ahead and grab that, drop it into our 3D scene so we get a little bit of context on what that looks like. So there's St. Mary's. So these hero buildings are kind of the icons. And you'll notice that in this case, St. Mary's has a bunch of friends around it, additional buildings. So let's grab all of those. And we'll call them So this allows us to georeference, import these 3D files, and start building in that context. Now, Geelong is a great case because of the quality of their data. So if we actually take a look at what they have, most cities actually have 1 or 2 heroes. Geelong actually has heroes for the whole CBD. So these are beautifully textured buildings. So we can use this process to go ahead and build out a 3D base map of all these really, really attractive, good-looking textured buildings for their kind of central business district. But if we're looking at St. Mary's here, we'll notice we got a couple places where we don't have points. We've actually got some gaps, so we're going to need another hero. We're going to need another way to fill in this context. And you'll notice that they do have building footprints for almost actually for the entire area. And these footprints actually have some smarts to them. So if I grab a footprint, let's see, take a look out in the distance. So if I grab this footprint here, the footprint actually is smart. It knows how tall it is. It knows how tall its roof is. It knows what kind of roof form it has. Through the GIS, it can query what land use category or zoning category it falls in. So it's actually geographic information that understands its 3D shape, even though it's only a 2D polygon natively. So what we can do is we can reach in, grab all these footprints, push them out, and push them into a procedural technology to create 3D models out of them. So this is City Engine. What I've done is brought in all these footprints, and I can grab these footprints and actually start generating 3D content out of them. And it's applying from a library of textures associated with the different zoning categories to kind of rapidly create 3D content for my 3D city. Now, the procedural technology that we're using here in City Engine actually also exists in ArcGIS Pro. So I can apply that same rule here and start generating 3D content on the fly in my scene. Or I can take that content, burn it, and store it in the geodatabase as a set of multi-patches, either way. But this is combined how I start to bring in, at least for the buildings, my kind of context around my city. So there's really 4 steps to this. One is the buildings. The second one is, now that we've got some attractive looking buildings and structures, we actually want to put some more interesting information underneath this so that we get the context. So I'm coming back to St. Mary's. St. Mary's is kind of my icon here. And what I want to do is add in higher resolution aerial imagery, in this case 10 centimeter, to bring in that context and make this look more attractive. Now that I've got buildings, I've got my imagery. It's draped actually on a high resolution train that's coming from LiDAR. I want to actually finish it out and start polishing that to really kind of make it snap. And I can do that by starting to apply rules or symbology to other data that the city's provided. So one of the great things about ArcGIS Pro, it's got this little window here called presets, where you actually have these procedural rules built in at the core for generating different types of 3D content. The city has a really, really comprehensive survey of vegetation, of tree types with heights, canopy size, et cetera. So I can reach in and grab that, drop it into this preset 3D layer. The preset 3D layer is going to interrogate that data, find any attributes that match what it needs, link those together, and use that to actually start generating 3D vegetation. And I could do this with other kinds of features. I could use street furniture. I could use streets themselves. I could use zoning categories. And I'll show a little bit of example of zoning in a little bit. But this gives me kind of my compelling 3D view. So you know what? I don't actually need this 2D view anymore, so I'm just going to dock it and flip away from it. And let's take a look at what we've made in a few simple steps. Right? Large data set. Actually, let me flip on the image-based map as a background, because that service only extends a certain distance. Large, complex data set, lots of textures, good-looking buildings, procedural context, all combined together into one large comprehensive 3D base map. And now I can take this whole scene, publish it out as a scene service, and have that as a base map that other people can use in other applications, be it a runtime or a WebViewer application. So now that I have this context, I actually want to start making changes to this city. Some proposed designs. So I'm going to zoom back in. So this is nearby the church, but not quite next to it. And I've got a series of parcels here that I want to redevelop. These parcels kind of cover 2 buildings here, and they actually have a procedural rule associated with them. So if I take a look inside the symbology properties of this layer, one of these layers is actually reaching out and grabbing a rule package from City Engine called zoning. And it's generating on top of it a zoning volume based on the regulations for zoning in that area. So let's quickly grab these existing buildings and get them out of the way. So I'm just going to select them. Bring up their attributes. Change their visibility. They disappear. Drop back in my my parcels. So these are my 2 development parcels. Now, the city's been working with an AC firm. They've been proposing a new development in an area, and they've provided a simple massing model of what that development's going to look like. So I want to add that development to my scene and see whether it violates my zoning regulations. So here I've got the new proposed building. I'm going to set it so that it actually sits on the ground. And then we can compare it to my existing zoning volume here in 3D and see where it might violate my regulations. And we can see it violates the regulations in a few places of this volume. And so now I have a choice. One choice is to tell the developer to change their proposed design, or if I want to be really nice and supportive, I could actually make a variance and modify my zoning features. So what I'm going to do is bring up the attributes. Remember, this is a procedurally generated feature. So I can go in and change the front setback. I'm going to make it 3 meters instead of 4. I'm going to change the left setback and make it 6 instead of 8. And the right setback, I'm going to make it 3. Kind of push out the size of the shape so that it's not so much in conflict. Make those edits. Save the changes. And we can see that the zoning volume has kind of grown to include more and more of that building. So I can not only procedurally generate features such as trees, but also regulatory volumes and use those as a guide to analytics. But as we saw, this specific building actually was a little bit taller than the zoning allowed. We're kind of concerned that this might have some negative impacts when it comes to shadows on adjacent buildings. So what we want to do is push this through some solar radiation analysis to see if it's actually going to negatively impact adjacent buildings. So I've created this solar radiation comparison model. It's using the solar radiation area tools built into Core ArcGIS. It takes the before and after, before the building's there, the existing structures, and then the new ones, combines them with the surface, calculates total solar radiation exposed for the winter solstice on June 22nd. And I can look at the results of that as a series of rasters on the ground. So here's what it looks like before they put in this new development. So, of course, the existing buildings that were there are much lower, so they didn't have as much of an impact on adjacent buildings. When we look at the proposed building, we can see significantly more solar impact in the area, especially on the adjacent sidewalk. But it doesn't look like it's going to reach out and touch many of the adjacent buildings. It's not going to impact right to light for instance, solar power, or doesn't look like it's going to significantly impact any of the buildings outside of the immediately adjacent buildings in terms of view to sky and view to sun and right to light. So just a quick way of measuring the impacts of one of these proposed buildings. So I had 2 parcels here that I wanted to work on, but I only got a massing model for one. So what I want to do is go in and actually sketch a model real fast of a proposed building. So I'm going to create some features. In this case, actually, I'm going to redock the 2D map on the right side, because sometimes it's easier to sketch and create features in 2D. What we actually have here is a feature editing template, and that feature editing template is attached to the procedural technology. It's driving the parameters for procedural generation. So I can grab a simple sketching tool, draw a polygon. Let's say I want to replace these 3 buildings with a new structure. I finish editing, and then we see in the 3D scene immediately, right, it's procedurally generated that form in 3D. And this feature, again, is live. So if I look at its attributes, right, I can actually start changing the different attributes of that feature. So let's select it. Bring the attributes, and we'll make it a 6-story tall building with a cement block, running block exterior. All right, so changing the style. So this gives me this very, very quick, easy way to rapidly sketch different kinds of buildings without having to manually hand model those things time and again. The display is up to you. It could be realistic or it could be thematic based on the usage type of that building. Buildings, of course, could have multiple usage types. So in this case, we have a mixed-use building that's part commercial and part residential. So I've been making some structures, and I want to better understand their impact on the surrounding environment. So St. Mary's is actually not just an icon, it's actually a regulatory requirement. There's a series of views to St. Mary's that we have to take into account whenever we're doing a proposal to see if it violates those views. So if we zoom out, right, so here is St. Mary's. And then there's a series of 3 critical views. Come on. There they are, the 3 critical views. These views have to be preserved and cannot be violated by any proposed building that we drop into this scene. So we can very, very quickly do a skyline assessment. We're going to grab those 3 critical views, views to St. Mary's. Grab the features themselves and generate those critical views. And then let's take a look, and if we zoom in, we can see that hopefully none of our buildings violate these critical views to St. Mary's. So just some quick on-the-fly analytics to see the impacts. So now this is a pretty rough proposed design, so I might want to continue to enhance and improve on this design. So what I can do is I can actually take it and export it at the City Engine. So do a clip and extract on the elevation and the imagery services, and then pull out all the multi-patch features, and then reach back into the city's geodatabase to grab other kinds of geographic features. And then bring those all into a City Engine scene to kind of add more realism and make it kind of more compelling. So here we have just that little section of the scene. City Engine is limited in terms of the amount of data it can have, so it's just a clipped section. The first thing we want to do is add in the context, the buildings themselves. So generate these, get the 3D buildings. Then we can drop in the same vegetation models using the same procedural rules that we had previously to create 3D trees. In this case, it's reached back into the database of Geelong and pulled in the streets. In this case, they had great attributes on the street width, and we could actually use that to drive the creation of street objects dynamically in 3D. So we can get really, really compelling looking street networks. The proposed building here that they got from the contractor, in this case what we did is we took it, we split it into its component pieces of varying height. Let's frame it so we can take a look. So it actually has many, many parts now, and on those parts we applied a procedural rule to generate a much more compelling form in 3D with some architectural detail. And in this case, we're color coding the interiors of the buildings based on the usage types inside those buildings. The reason we care about that is if I select this building, the procedural rule is not just calculating and generating the geometry, but it's also giving me performance metrics based on the usage profile inside that building. So if I look at the metrics, I can see the building's estimated total electrical consumption, heating energy consumption, domestic waste production, gray water, black water, water recycling, total domestic trash, total gross floor area, and the floor areas of all the different usage profiles within that building. So this is taking it one step forward. We're not just generating cool visuals, we're actually generating information on tops of these buildings and structures. Now, as before, I have this other parcel here that I wanted to develop. But rather than manually create buildings footprint by footprint, one of the things I can do is I can ask CityEngine to automatically subdivide that available lot into blocks, and then have it apply the same rule that I just used on that other building to generate a 3D structure. And I can do that for all these parcels. Right, to rapidly create a potential 3D model. And these forms are actually being driven by zoning regulation. So setback, step back, maximum height are being pushed into it, and then the building is generating inside till it finds its maximum. And these, of course, are all dynamic buildings, so I can go in, manipulate their attributes, and change the way they appear. So let's say I'm going to drop this down to a 4-story building in this case, and all those metrics change in the background as well. So once I've got my design, my improved design, that's more visually compelling, I can actually reach in and share that back out to my GIS. So I can grab this model, export it, take it out to a file geodatabase, bring it back into ArcGIS Pro, and redo those assessments that I did before, redo the shadow analysis, redo the line of sight. Or I can actually take it and push it out to the web. So maybe I want to export it to a web scene, and I want to give somebody else the ability to reach in and actually take a look at that in a web browser without having to have any 3D technology. So this is that, again, same scene, same buildings, same data, but now all shared just in a browser. And this could be done either as a static scene, one-time publish, or it could be done as a set of services on ArcGIS Server that's streaming into the web viewer. And this maintains all the metrics associated with it. So if you grab a piece of it, you can actually still see the electrical consumption, the water consumption, et cetera. And this is how you get it into the hands of the real heroes, or the people who are trying to make those decisions and kind of improve their city and do better designs and better plans. So hopefully that gives you a little overview of how we go from starting with just a base set of data, creating a 3D city, improving a 3D city, doing a design in a city, doing a couple simple pieces of analysis, saving that, publishing it, and sharing it with the public. Thank you very much.